Alright, Unit 6, Lesson 1, we're looking at different attributes of a quadratic. So the word attribute is just a fancy word that means a characteristic. So we're looking at characteristic. We're looking at different pieces of a quadratic, how a quadratic looks, specific points on the quadratic, domain and range, things like that. So if you recall, standard form of a quadratic is ax squared plus bx plus c. And the graph of a quadratic forms a parabola, so something like this. Now, we say that this quadratic is open upward because it's open at the top. The way that we'll know a quadratic is open upward is if this first number, the number in front of x squared, we call it the leading coefficient, if it is positive, so if a is positive, then we get a quadratic that's open upward. If a is negative, so if my leading coefficient is negative, we have a reflection over the x-axis, and we say this is open downward. So if a is negative, then we get a parabola that flips the opposite direction, and it's open downward. Now, a key point on a parabola is what we call the vertex. Now, the vertex can either be a minimum or a maximum of the quadratic. So our vertex is going to be, if it's open upward, the vertex is a minimum of the quadratic. It's the lowest point on the quadratic. So here's my vertex. When it's open upward, I get a minimum. If my quadratic is reflected over the x-axis and it's open downward, then my vertex, again, it's where it curves. This is my vertex. And now the vertex is a maximum of my quadratic. So to find the vertex, we have a nice little formula. The vertex is a coordinate or a point. And to find it, the formula for the x value is negative b over 2a. So that's the x value, or the h, when we look at the formula in just a second. And to get the y value, we're just going to take what we got for the x value and plug it back in to my function, like this. I know it looks crazy, but we're going to do an example. So let's say that I have f of x equals negative 3x squared plus 12x minus 7. And I want to find the vertex. So to find the x value, I need to take negative b and divide it by 2a. Well, standard form is ax squared plus bx plus c. So negative b just means the opposite of the number in front of x. So I have positive 12, so that'll give me negative 12 over 2 times my leading coefficient, which is negative 3. So I get negative 12 over negative 6, which is positive 2. So that gives me the x value of my vertex. Now, to get the y value, I'm just going to take the 2 and plug it back into my equation. So I'll have negative 3 times 2 squared plus 12 times 2 minus 7. And you could just plug that in your calculator. But negative 3 times 2 squared, that gives me negative 12 plus 24 minus 7. So I get 12 minus 7 is equal to 5. So the vertex of my quadratic is 2, 5. Now, looking at that quadratic, again, I have negative 3x squared plus 12x minus 7. My leading coefficient is negative, so that means that my quadratic is going to be flipped upside down. It's open downward, so I know that my vertex is a maximum. Okay. We also have what we call vertex form. And we've seen this before when we were looking at transformations. So vertex form is f of x equals a times x minus h squared plus k. The h and the k come from my vertex. Another way to write the vertex instead of the x and the y is h, comma, k. So once we find the vertex, we can write it in vertex form. The a value is just the leading coefficient from my function. So I'm going to rewrite f of x equals negative 3x squared plus 12x minus 7. And now I want to write it in vertex form. So I'm going to have f of x equals, I'm going to move this out of the way, equals a, which a is my leading coefficient, so negative 3, and then x minus h. So this just means the opposite of h. The h for my vertex is 2, so I'm going to have a negative 2 in there, so x minus 2 squared. If the x value for my vertex were already negative, then I would have plus on the inside. And then just plus k. The plus means that whatever k is what my value will be here. So my k is positive 5, so I'm just going to have plus 5. Say the y value was negative 8, so I would have negative 8 right there. Now that I have it written in vertex form, we looked at this when we were doing transformations. Remember that what's inside the parentheses, so if I have a number in front of x, or this value right here, this indicates horizontal transformations, and remember that they're the opposite. So this minus 2 tells me that my parabola shifts to the right 2 units. On the outside, so the value out front and the value in the back, these are my vertical transformations. So the negative is a reflection over the x-axis. The 3 tells me that I have a vertical stretch, right? So it's going to make it skinnier. And the 5 tells me that I have a shift upward. So anything on the inside is a horizontal transformation. Anything on the outside is a vertical transformation. Now, one more attribute that we'll talk about is the domain and the range. Remember, domain are the x values that you can plug in. My quadratic, I'm just taking x values and adding or subtracting and then squaring. So I can have any x value. So no matter what your quadratic looks like, your domain and range will always be negative infinity to positive infinity. And remember, there's nothing I can add, subtract, multiply, or divide infinity by that will change it. So your domain will always be negative infinity to positive infinity. Now your range, we can figure out what the range is just by the vertex. I know the y value is 5 on my vertex, and it's a maximum. So this is the highest the y value will ever be. Everything else will be less than that. So I know that my range will be negative infinity all the way up to 5, and 5 will be included. Okay, so let's do an example real quick, just looking at another vertex of how to find my domain and range. So let's say that I've already figured out the vertex of some function, and it's, I don't know, 7, comma, negative 9. And say that I know it's a minimum, right? So my parabola is open upward, and so I know that my vertex is a minimum. To find the domain never changes. It's still going to be negative infinity to positive infinity. My range, now, since I know that my vertex is a minimum, that means this is the smallest value my vertex will ever be, and anything else will be greater than that, right? So it's open upward. So I'm going to graph this real quick. I'm at positive 7, so here's 7, and negative 9. So here's my vertex. I don't know what the function looks like, so I'm just kind of winging the graph. It looks something like that. So my range, the lowest point is negative 9, and it goes up from there. So my range would be negative 9 to infinity. So your vertex, and whether it's a minimum or a maximum, will dictate what the range of that parabola is. All right, I hope y'all have a good day. If you have questions, of course, come and harass me. And that's it.